Welcome back. In this video, we're going to learn about the structure of an atom. We'll also talk about isotopes and how to interpret atomic symbol notation. We'll discuss how to calculate the number of protons, neutrons, and electrons for isotopes and ions. And we'll also talk about the average atomic mass of an element and relate that to its isotopes and percent abundance. So an atom is the smallest unit of matter that corresponds to a given element on the periodic table. Atoms themselves are made up of even smaller pieces of matter. They consist of the nucleus and the electron cloud. And within the nucleus, we have protons and neutrons. Protons are positively charged, neutrons are neutral, and the electrons within the electron cloud are negatively charged. Now, an atom is mostly empty space. And the reason for that is you can imagine that you have the nucleus in the center, and the electrons are kind of floating around, if you will, all throughout surrounding that nucleus. And so they can be thought of as occupying that given space, but the electrons themselves are very, very small. Think of it like balls bouncing around in a room. So they can bounce back and forth across the room to fill that room, but they themselves actually take up very little space. And that's kind of like what's going on with electrons. And if we compare the size of the nucleus to the size of the atom itself, it's a factor of about 10,000. In other words, the nucleus is 1/10,000th the size of the entire atom. An isotope is a given element, or an isotope of an element rather, is an element that has the same number of protons but differing numbers of neutrons. So when we define an element based upon the atomic number, which is the number of protons. However, depending on the number of neutrons that we have in an element, that will give us a different isotope. For example, we have carbon, which has 6 protons. Doesn't matter which atom of carbon we examine, it will always be carbon because it always has 6 protons. However, what can change is the number of neutrons. In this carbon atom, this one would be carbon 12. And this describes this particular isotope because it has 6 neutrons and 6 protons. However, we do have different isotopes of carbon. Carbon 12 and carbon 13 exist much more commonly in nature than carbon 14 does. And so we can describe the average atomic mass of an element as a weighted average of each of the different isotopes. So when you look at the periodic table, you can see that the atomic mass that's listed for carbon is 12.0107 grams per mole, or AMU, atomic mass units. However, that doesn't correspond to any of the individual isotopes of carbon, but rather it's a weighted average. And the way that this is calculated is by taking the sums of each of the atomic masses times its relative abundance in nature. So carbon 12, for example, is actually found if you had a big bucket of carbon atoms, about 98.93% of those would be carbon atoms with 6 neutrons, or carbon 12. For carbon 13, just over 1% of the carbon atoms found in that bucket would be carbon 13. And such a small amount would be carbon 14 that it's essentially 0. So if you were to take and multiply the atomic mass of each isotope times its percent abundance, you get the value that's on the periodic table. And so the significance here is that a a given element, as represented on the periodic table, is not just one isotope, or in most cases, it's not one isotope, but it's really combining all the different isotopes that we find in nature. Let's try a couple problems here. So, which of these is not an isotope of silicon-30? I'd like for you to pause the video and try this on your own. Welcome back. So, when we're looking at isotopes, we are looking for elements that have the same number of protons, but different numbers of neutrons. So with choice A, this is an isotope, and the isotope would be silicon-29. And the reason for that is because it has a different mass number, but the number of protons is the same. We have 15 neutrons, 14 protons, so our mass is 29. And so this indeed is an isotope of silicon. Again, same number of protons, but different number of neutrons. Now, B is also an isotope, and for the same reason. We see here that this is silicon, and we can tell that both by the number of protons represented, which is 14, or by the fact that we have the elemental symbol of silicon. And in this case, we only have 14 neutrons because the mass number here is equal to the sum of the number of protons and number of neutrons. Now, what about atom C? This cannot be an isotope of silicon because it has a different number of protons. This has 16 protons and 14 neutrons. So while the mass number is the same, it's a different element. And indeed, this is sulfur. All right, let's try one more problem here. I'd like for you to identify the correct symbol for an atom or ion that has 8 protons, 9 neutrons, and 10 electrons. Pause the video and see if you can figure this one out on your own. All right, let's see if you figured it out. So the elemental symbol is going to come from the fact that we have 8 protons here. And that atomic symbol we have here on kind of a larger font. The mass number is in the top left-hand corner, and that is the sum of the protons and the neutrons. And then the atomic number, which is represented by the symbol Z here, is the number of protons. So since we have 8 protons, we would have an element of, which is oxygen, and you can find that from the periodic table. Since we have 9 neutrons, the mass number must be 17 because the mass number is the sum of the protons and the neutrons. And when it comes to the number of electrons, we compare this to the number of protons to determine the charge. So since we have 8 protons and 10 electrons, we have more electrons than there are protons. So our overall charge must be negative. And since it's a difference of 2, our charge is going to be -2. And so that gives us answer choice E as our final answer. Thanks for watching. Have a great day.